All right, welcome to part 2 for our angle of depression word problems. So for rounding, we're going to round to the nearest hundredth of a foot for distance and the nearest degree for an angle. So angle depression problems are harder, not going to lie. So you've got a little boy standing on a cliff. So let me draw a cliff. I'm going to draw a hill because that's all I can draw. So you have a little boy standing on a hill or a cliff. And above water, so we just draw water. He sees a boat. Draw a boat. Okay, that is 200 feet away from the base of the cliff. So what I need to do, it is 200 feet away from the base of the cliff. And it is 315 feet away from him. So from this person to this boat is 315 feet, okay? What is the angle of depression from him to the boat? Now, the most common mistake is you're going to want to mark this angle up here, okay? But this angle is not the angle of depression because when this person is looking out, it is this angle right here, which is the same as this angle down here. You've got to draw this eye level or this horizontal line before you can have the angle of depression. Or you can always remember that the angle of elevation is at the bottom, okay? So I'm going to look at this triangle from an angle of elevation perspective, okay? Because I like dealing with triangles that are right side up. So this side is going to be opposite. This is my hypotenuse, and this 200 is my adjacent. I don't know anything about the opposite side. So I've got adjacent and hypotenuse, which is cosine. And cosine, since I'm looking for the angle of depression or elevation, I'm going to use x. Cosine is adjacent over hypotenuse. So I'm going to take the inverse cosine of 200 over 315. Now remember, make sure you're in degrees. But when you do inverse cosine, you should get 50.5. So it's going to round to 51 degrees. So the angle of depression or the angle of elevation is going to be 51 degrees. Okay? Now, you could have looked at your right triangle upside down like this and saw that this side would be also 200 and then this side would be 315. So it's all up to you whether you can look at a triangle upside down or not. So let's look at another example. So thankfully these are all drawn for us. So you have a princess on top of a 167-foot tower. So I know this tower is 167 feet tall, looking down at an angle of 37. So notice they drew the eye level and then they drew the angle of depression, which is the same down here, okay? How long is the rope? And the rope is attached to a package on the ground. So I'm looking for this. She's holding a piece of rope to a package on the ground. So again, I don't like looking at my triangle upside down. I like looking at it right side up. So this is going to be opposite, and this is going to be my hypotenuse, which means I need sine. So sine of 37 is going to equal opposite over hypotenuse. So x is down low, so I'm going to switch them. So x equals 167 over sine of 37. So when you divide those, you should get 277.49 feet. So that's how long the rope is attached to that package on the ground. Okay? Again, let me know if you have any questions at any point. Otherwise, we're going to keep moving on. So you've got an airplane at an altitude of 1,200 meters. So remember, altitude, the up and down line. Notice we've got a right triangle there as well. The angle of depression to a building on the ground measures 28. So again, angle of elevation is on the ground, or you could have said angle of depression up there. Again, I like looking at my triangle and write that up. Find the distance from the plane to the base of the building. So from the plane to the base of the building, that'd be our x. So I have a degree, I have an opposite, and I have the hypotenuse, which means that would be sine. Sine of 28 equals opposite over hypotenuse. X is down low, I'm going to switch it. So when I do 1,200 divided by sine of 28, you should get 2,556.07 meters. So that is how far it is from the plane to the base of the building. Okay. Last problem, and then we're going to do some U-tries, and you get to draw. So you've got a sonar operator on a battleship that detects a submarine at a distance of 500 meters horizontally. So that's a key. Horizontally would go right here. And then angle of depression is 37. Okay. How deep is the sub? Okay. We measure how deep something is by dropping a line straight down. So I've got an upside down triangle, which I'm going to have to deal with right now. So that's my opposite. That is my hypotenuse, which means this side is my adjacent. O and A would be tangent. So I've got tangent of 37. It's going to equal opposite over adjacent. X is up high, I'm going to cross multiply. So do tangent of 37 times 500. Should get 376.7, and then that would round to an 8. And we got meters. So that is how deep the submarine is. Okay. So again, this is how you solve angle of elevation and depression problems. Make sure you draw a picture if it's not drawn for you, label the important information, and then figure out what trig ratio to use. Now you have a U-try. So you've got 2 angle of elevation problems, and then you have 2 angle of depression problems. So press pause, try that 8, 9, 10, and 11, or 9, 10, 11, 12, and we'll go over them. Let's talk about these 4 problems. So you have a boy flying a kite. So you had to make sure that that kite was apart from the boy, because when you put a kite up in the air, it goes the opposite direction, otherwise it wouldn't be flying in the air. And it had 100 feet of string. So you've got the person holding a kite with 100 feet of string, making an angle of elevation of 40 degrees. So it didn't give you an eye level, so we just knew that this angle right here would be 40 degrees. How far away is a point on the ground directly under the kite? So now this was a little tricky. When it asks how far away, that typically means horizontal distance. So it's okay if you put it here, but more specifically, far away means on the ground. So you're looking for how far from the boy to a point on the ground. So you would do adjacent and hypotenuse. And so you would use cosine, x is up high, cross multiply, and you should have gotten 76.60 feet. Okay? Let me know if you have any questions on that one. Right here, you had a building at 8 in the morning casting a shadow of 75 feet on the ground. The angle where the ray from the sun met the ground, so angle is going to be on the ground, was 50 degrees. How tall is the building? So how tall is it? So you got opposite and adjacent. So I used tangent of 50 and then got 89.38 feet. Okay. So if you have any questions on that, let me know. On these, you had to round to the nearest degree. So you had an escalator from the 2nd floor to the 1st floor of a department store. Was 110 feet long, so I got a little sloppy with my escalator. And then falls 32 feet vertically. So vertically means up and down, so it fell 32 feet. So here was your right angle below that escalator. What angle does the escalator make with the 2nd floor? So you could be looking for this angle up here, or you could be looking for the ground floor, because the angle of depression and elevation are the same. So I had opposite and hypotenuse, which was sine. Since I was looking for the angle, I did the inverse of sine and got 17 degrees. All right, lastly, we've got the Leaning Tower of Pisa. Drew my best impression. And you had a rock that was dropped 182 feet from the top. So a person dropping a rock down there fell to a point 14 feet from the base of the tower. So from the tower's base to where that rock landed was 14 feet. What angle does the tower make with the ground? So I was looking for what angle did this tower make right here. I had opposite and adjacent, so I used tan. The inverse tan gave me 86 degrees, which kind of makes sense. So that Leaning Tower of Pisa is off by 4 degrees, which is interesting. Okay, so again, those are how you solve and draw angle of elevation and depression problems. Again, these are tricky. Drawing the picture is very hard if you cannot visualize it. So practice, 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 and thank you for watching.